All right, great. So we have Dr. Ptáček representing the Society for Research on Biological Rhythms, a professor of neurology at UCSF, and really excited to have you speak with us today.
Thank you so much, Julie. It's a pleasure to be here. Thank you for the opportunity. So I'm representing the Society for Research in Biological Rhythms, which is an organization of scientists, clinicians, and industry experts promoting basic and applied science in biological rhythms or circadian rhythms. We want to be advocates for research on sleep and other biological rhythms through interactions in forums like this one. So I'm grateful that we're able to participate with you. So in our social constructs, including when school starts and when the typical job start time is, these don't always fit very well with the biology, which is telling us when to get up and when to go to sleep. And we know that school start times do matter, and that in some studies where school districts have started later, that quantifiable scores on tests like SATs have gone up. And so children, and particularly adolescents and young adults, tend to be much more night owls than we are as we get older. This doesn't fit so well with school start time sometimes. And so this is one important area where SRBR has done a lot of work. Now, as humans, it's important to note that sleep is a behavior, and I'm focused and interested on understanding normal sleep, which I think is going to be critical to being more effective in treating sleep disorders. But we really began to muck around with our biology when electric lights were invented, because now we could have unnatural light late at night, which tells our clock that the sun is still up, and we can turn them on early in the morning. And we also use alarm clocks and other things, coffee and other stimulants to get us up. So getting healthy light, that is light during the solar day, is really critically important for our health. And we also know that in terms of treatment for many diseases, that medications can have very different effects depending on whether they're administered early in the day, in the circadian day, or late in the circadian day. And other things like fasting, feeding, metabolism, and many other things can impact on the circadian clock. Well, we've learned a lot starting in the early 70s with the work of Seymour Benzer, and then with the cloning of the first Drosophila circadian gene in 1984, about the molecular aspects of the clock and clock regulation. And this was the subject of the Nobel Prize in Physiology and Medicine 4 years ago to these three gentlemen. Sadly, Seymour Benzer was deceased at this time, but I really think Seymour should have received the Nobel for his work with Ron Konopka early in the beginning of this field of behavioral genetics and circadian genetics. But that this prize was awarded has led a lot of people to think, oh yeah, the circadian clock is understood and there's not a whole lot more to learn there. Well, nothing could be farther from the truth. In humans, we're talking about behavior, sleep behavior, and genes are critical to that behavior, but it's also very complicated because of the environment, the social, family structure, cultural elements around us that affect how we express our genetic predisposition to sleep and wake. And so the human organism offers real challenges for this very reason, but also incredible opportunities. We know that in the general population that the distribution of biological tendency to wake up or at a particular time or go to sleep at a particular time spans a huge spectrum. And when our work is focused on looking at the very tails of this distribution, and then through this we've identified familial forms of morning larkism or night owlism, if you will. And so these as geneticists, both in Drosophila, well, in any organism, Drosophila, but certainly for us in humans, by studying the tails of this normal distribution, we can find strongly genetic forms of circadian sleep behavior. And this has allowed us to make a lot of headway in the human genetics of this. Now, of course, all the variation in the middle of the distribution is also genetic, but it's much more complicated. And people are applying, are studying big data to try to understand this genetic variation. But it's so complicated that I'm less optimistic that that's going to be a successful undertaking. But this is one thing I find really exciting. In the familial form of ASP that we've characterized and shown to affect 0.3% of the general population, mutations in known circadian genes that the fly guys and the mouse guys and we have identified in humans explain less than 15% of all of these families with normal but extreme circadian variation. So this tells us that there's still a huge amount of stuff to learn, and I think it's going to require the human organism to get at this, because the 85% that we're missing in these families was not ever discovered in other model systems. So I think of the circadian clock, our bodies like an orchestra, a bunch of different instruments, all good musicians who know how to play music and keep a tempo, but we need our central core clock, the suprachiasmatic nucleus, as the director of this orchestra to coordinate all these different clocks working inside different parts of our brain. The rhythms are being affected by when we eat and how we eat. They're affected by activity, social aspects of our lives, light that we get from the sun and from artificial sources, and clocks in all of our peripheral tissues. All of our organs are oscillating in circadian ways, and thus it's not surprising that sleep disruption and circadian disruption can lead to increased risk of many diseases, including cancer of many of these organs, cardiovascular disease, stroke and neurodegeneration in the brain, metabolic disease and diabetes, et cetera, et cetera. So sleep is critically important to our health, and all of our cells in our body are cycling in a circadian way, but they're all orchestrated by the director up here in our brain, the suprachiasmatic nucleus. So as I said, it's not surprising that all of these disorders, virtually all disorders, I would venture to say, we're at higher risk for those if we're not sleeping in sync with our circadian clock and if we're not getting adequate sleep. But we heard from Dr. Das about short sleep in the general population. I also want to take this opportunity to remind you that she was talking about sleep deprivation, people sleeping shorter than they should. A lot of people think we should all sleep 8.5 hours per night. That is simply not true. There are some people who only need 4 to 6 hours to perform well, to feel good, and to be healthy. And there's some people who require more, 9, 10 hours of sleep per night. And so just depending on what your general need is, sleep deprivation from what your biological need for sleep is bad for our health. And again, human genetics is going to teach us a lot, because my colleague Yingwei Fu has described the natural short sleepers and also has collected families with natural long sleepers that has allowed cloning of genes that cause the very most extreme and more strongly genetic forms of short sleepers and long sleepers. And here, Dr. Fu has more than 100 families and identified 4 genes that are published and a couple more that are not. But these describe less than 5% of all these FNSS families. So these are normal variants in the general population. This is not disease, but it is my great hope that by identifying the pieces of the puzzle, we're sort of where Alzheimer's was 30 or 40 years ago. We understand so little about what normal sleep is and what normal sleep requirement is, whatever that is. And so identifying these genes is going to allow us to begin, us and many other people, to begin studying molecular pathways in much greater detail that regulate the requirement for human sleep and the efficiency of human sleep. And we need to apply this science as that we've, as a field, have accumulated over the decades, and what we learn moving forward to better care for patients. And this includes, the best timing for taking medications. And it's different for different medications, I'm sure. Some of these have been studied, but many have not. Many drugs we don't know yet. We have to be sensitive in our buildings about natural lighting, circadian awareness of lighting. We've already heard about the ICU and the hospital in general, where sleep is often very disrupted and lights can be on 24 hours a day. Our operational procedures like school start times, work start times, feeding times, etc., and ensuring that people with circadian disorders are seen by specialists who can help them, because often this is an unmet need, not for the genetic forms that I'm talking about, but for circadian disorders. And so I'll stop there and turn it over to Dr. Mullington.
Thank you so much for sharing. I think it's really exciting and a huge honor to have you share with us today.